I'm trying to just be generic and not really. I'm like kind of saying make sure I can implement Factorio. I don't want to actually do Factorio exactly, but since I haven't thought through what the way the sim should work, it's just a starting point. Okay, everything else is zeroed. We'll say that the timer. Well, we'll see. Okay, and then we can accelerate find machine here because we now have, what is it called? Logic chunk cord. So this is the searched for coordinates. Unpacked box X. Y. Unpacked Z. And then we can just check if CR machine dot pause dot packed equals SE dot packed. So now it doesn't have to do any bit field math while it's doing this loop, and this is going to be potentially one of the slowest things in the system, maybe. Hopefully we don't call find machine very often. We call it when you're destroying a machine, but that's, you know, not something we call 100 times per tick or something. Per tick, we'll just iterate over them, and hopefully we don't have to search them. We'll see. We'll see how that all shakes out. Yeah, now you have other kinds of machines, like if we did Factorio style inserters that transfer between belts and machines. So they'd kind of prefer to store the belt ID, the target IDs, sort of, which would be 2 UINT16s, and then they would need a timer. They would need an output buffer. So I might want to make this a union. So it would be those 4 bytes would be shared, and then they would need an input and an output, which is each 2 bytes. That would exactly fit. Or they could be stored in a separate array, which might make sense too. Alright, let's try and see what we got here. These are backwards. Bit fields aren't really important except when you're trying to do really large quantities of things. You can always do the packing by hand with shift right here. Bit fields aren't really important except when you're trying to do really large quantities of things. You can always do the packing by hand with shifts and masks, and you can often do things more efficiently if you do them, but bit fields let you just get it going and working fast. You can't always beat the Gemaier speed, but you have the opportunity to beat its speed. Alright, so that claims to have worked. So then we just want it in the tick to have worked. Alright, so that claims to have speed. Alright, so that claims to have worked. So then we just want it in the tick. Logistics tick. First we gather all the belts. And we sort them, and then we process them. You know, we probably actually ought to cache that and only rebuild it on change. Okay, so if it's a long tick, let's go ahead and to make this a separate function, just to reduce our nesting depth. Although, yeah, I wonder what I should do about having multiple speeds for belts. I could run long ticks twice as often, but the slow belts only, I think they need to keep their own belt runs though, like their own sorted topological sort, and treat them, transition between them specially. Why did I delete the call for that? Oh, I copied it. That's why. All right, so why does that not get zeroed? Oh, it gets zeroed in here somewhere. All right, so first we process all the belts. First we want to consume from all the belts. So yeah, this is really dumb. We're going to traverse this so many times per tick. I really need to build a list of non-empty slots. Oh, I pluralized belts, and I didn't pluralize machines. No, I didn't. CIBR. Right? Yeah, okay, whatever. Is block type or eater. And x0 timer equals 0, so it's ready to consume again. Then, what can be packed better with shifts and masks than with bit fields? Basically, what can be packed better with shifts and masks than with bit fields? Basically, if you want to update two fields at the same time or test two fields at the same time, the testing is a really common one. Like, you know, you have some complicated logic tests, or semi-complicated. You know, I want to test that it's this type and this rotation, and those are both packed with bit fields into the same spot. The compiler may or may not figure out a more efficient test, depending on where they do that and such. But you even have the option of picking your enum or rotation values such that that complicated test you can guarantee can be tested all at once in a special way. Like, you know, say they're both 2-bit fields, you might have a test that you can arrange such that if you look at the whole 4-bit value at once, it has to be greater than, you know, 7 or something like that. That you've arranged all the cases. Oh, that's not greater than equal to 7. You've arranged all the cases. Whereas if you there's no guarantee the compiler is going to like notice that, you know, if x, whatever this would turn out to be, this is like if x is like assuming this is equivalent of that. So it's, you know, if x is, so this is x is type 2, or x is type 3, or x is type 1 and y is 3. Like that, you might have these, if these are enums, you might have written it out like that. And there's no guarantee that the compiler, and these are bit fields, there's no guarantee that the compiler is going to notice that that is equivalent to accessing the entire thing without doing a bit shifts or anything, and just going like that. So the compiler might do all these bit shifts and stuff to check all these values. It's a sort of artificial example trying to explain it, but it's an actual real thing that happens. The optimizer doesn't always figure that stuff out. And it gives you the opportunity to arrange those explicitly, to make sure that that can be tested in a single thing. Like if that were the single most important step in the entire, if you're just testing that everywhere constantly, like that's the single most important thing for performance, you could organize that to work. You could still technically do that with bit fields. You just don't know that the compiler is going to do the right thing, and it requires you to actually look inside and see what order the bit fields are stored in and stuff like that. So you can't necessarily do it portably, although I think most compilers do the same thing. All right, so if the timer is 0, we're ready to eat. We need to know where to eat from, but we're not storing that. Because I think I want to do the inserter style thing of Factorial, have machines dedicated to doing that, and then those machines can pre-store those coordinates instead of having to look them up. So we have to figure out where it outputs to, which is sort of like get target chunk, but we have to do it all by hand. Yeah, okay, so static void get facing chunk. So x int by int z. No, so we actually want the coordinate, the actual coordinate of the object, and the direction. And I don't actually need the offset x, y, z for these. We don't take the target chunk. Or target chunk, right, that's the output. I guess we want to set the offset. But we're going to have a different meaning. In the other one, it's relative. But we don't need the relative coordinates at all in this case. So we just want the Or do we? Then we have to find what belt is there. How do we find a belt? I think we use does belt intersect. Which requires us to loop. Let's just do this all. Let's just get rid of that function that I started to write. Let's not do it like this. Get belt. Belt. Right, so we have to find that. We have to get the chunk. We have to compute this. These are EX, EY. Don't know what I was doing there. Look at that. We say the belt can't be a ramp. Okay, then we found the belt. And then what are we going to do with it? We're going to actually interact with it. We're going to put stuff on it and take it off. So I think all we need to do is return. Oh no, we need to know where on it things are. So we need the relative offset. And we actually want to know, actually we just need to know how far along the belt this target point is. So we'll just return two variables rather than trying to put it in a struct. And this doesn't use target chunk at all, so let's move it up before it. So we have to do this. We have to say the actual physical offset is okay, where's the belt actually located? The belt is actually located at slice x times log chunk X. Is that how that's spelled? Size Y. Plus the offset within the chunk. Easier equals, we need this SID, which is easy. This is something called something else. Logi. Oh, it is called Logi chunks, I see. Okay. We need the old Z quantized to since it's not allowed to be sloped, it will always be the same one. But so that needs to be quantized to little Logi chunk size Z. That's one. That's quantized. Plus. Oh no, wait, we want the belt. Okay, so that's the position of the start of the belt. XYZ is the position along the belt, so pause equals start pause equals absolute EX minus X plus absolute EY minus Y. So, yeah, I tend not to do math. I mean, yeah, I tend not to do math. I mean, actually what's going on with the bit fields when you do math is they get converted to full-sized ints or whatever sized ints. You do all the math and then they get converted back to the file size. Although with the whole integer overflow mess, who knows about that? But I believe they're just always promoted to that. So, you know, bit shifting assigned one is still bad or whatever. Although I'm sure I do it. So where was that code? So not the belt tick, but the long tick. Here it is. So we need to get interaction. Oh, was that what it's called? And we take this machine's location, which is slice X times Logi chunk size X slice Y times Logi chunk size Y. K times Logi chunk size Z, and but so you know, bit shifting assigned one is still bad or whatever. Although I'm sure I do it. So where was that code? So not the belt tick, but the long tick. Here it is. So we need to get interaction. Oh, was that what it's called? And we take this machine's location, which is slice X times Logi size X. Slice Y times Logi chunk size Y. K times Logi chunk size Z. And then facing. No, well, that's not auto completing. And how far along the belt? Okay. Then we see, is there something there to eat? So we need to know, oops, I didn't actually store that. Oh, run. are. Okay, so then we need to know which side. So let's say if the belt is leading straight in, we can eat from either side. And if it's on the side, it can only eat from one side. And if it's facing away, it can never eat from it. So you need to know the... Do we just need to know, look at the relative rotations? Does that always tell us? I think it does. Because otherwise we wouldn't be looking at this spot. So switch belt run rot face. What is the origin? Of course. Minus X rotate. I call it rot or rotate. Rot. Consistency, not important. Okay. So if they're facing in the same direction, then nothing happens because the belt is moving away from the thing. If they're facing head on, we can consume either one. And then these can only consume from one side, and I don't know which side, so we'll just implement something and see whether I got it right or wrong. So if we are items of some sort, cost times items per belt, this doesn't need to be an STB array because we're always storing the length explicitly. I should fix that. Save a little memory. If that's not 0, then let's consume it. Actually. That's about to animate forward, so let's do that. And then set the timer so it takes a little bit longer for us to eat again. And this has to be from the other side. And then if it's head on, either one, but we want to eat the frontmost one, which is and we don't want to eat from both of them. Not returned here, break. Okay, maybe. And then after all the belts have simulated, then we can output one. And also decrement the timer. Alright, so machine is not the right name anyway. That's why this was not working. It's machine info. That's why it's not getting any autocomplete. Need final break in case 2. Thank you. Thank you. 2. Need final break in case. Need final break in case. That's why this was not working. It's machine in name anyway. Machine is not the right. All right. So machine is so machine. All right. So machine is not the right name anyway. That's why this was not working. It's machine info. That's why it's not getting any autocomplete. Need final break in case 2. Thank you. Unreferenced I. Dot type. I think. Yeah. Things on belts should actually never have anything other than type. I think I can get rid of that extra indirection there. Or it's not really indirection, but extra. Logistics do long tick. Logistics do long tick. Logistics do long tick. Get interaction belt. Return negative or return null. Get interaction belt. Handle the null case. If BR is not equal null. Okay. Let's see if any of that works. Let's see if any of that works. Heh, yeah. Heh, yeah. Did I forget to save it again? I guess I did. Oh, no, I didn't. I just forgot to turn on the load. Woohoo. Why would this break? TB item pos is garbage. So is pos garbage? Is that why that's garbage? Yep, pos is garbage. Where did pos come from? Came from that computation. EX, EY. TC off X. Oh, I probably broke the, I must have broke that, woohoo. Why would this get target chunk? Must have changed that accidentally when I was messing with this stuff. No, I don't think I did. Oh yeah, I lost the setting the value of off X, off Y. I copied that up here and then deleted it. I lost the setting. Oh yeah, I lost the set. Oh yeah, I lost the setting the value of off X, off Y. I copied that up here and then deleted it. I cut and pasted it instead of copy and pasting it. Off X equals. I don't remember what it was. I think it's EX minus BX. That seems not right. Ah, yes. Can I copy paste that? So now let's spontaneously generate some stuff and see if that does anything. Nope. All right, let's find the ore heater. Find the ore heater. All right, let's find the ore heater. Is this ever getting run? Did we create the machines? Apparently we didn't create the machines. Okay, create machine. Oh, I never pushed it in the array. Like an interesting thing you can learn. Like an interesting thing you can learn research this is that I realized that bug before I actually looked at the code. Like, I was confident that I would have actually remembered having done it, and I didn't remember having done it. So it wasn't like maybe I didn't. It was I didn't. All right, let's find the ore heater. Is this ever getting run? Did we create the machines? Apparently we didn't create the machines. Okay, create machine. Oh, I never pushed it in the array. Like an interesting thing you can learn research this is that I realized that bug before I actually looked at the code. Like, I was confident that I would have actually remembered having done it, and I didn't remember having done it. So it wasn't like maybe I didn't. It was I didn't. Right. Warrior. Warrior. Okay, now we get here. And is BR null? BR is null. Okay, so this isn't working. Because I'm not passing in the right thing anymore. I'm supposed to pass in the machine address. Oh, because I forgot to put that in. X pause unpacked. X pause unpacked. Y X pause unpacked. Okay, so this isn't working. Because I'm not passing in the right thing anymore. I'm supposed to pass in the machine address. Oh, because I forgot to put that in. X pause unpacked. X pause unpacked. Y X pause unpacked. did we find the belt? BR is still null. All right. Let's step in. So these should be world coordinates. Okay, there is one. Then we're going to test, does belt intersect? Z off was not Z. Easy is 5. And that's 4. Oh, because they're at different heights. Yeah. The conveyor belt is not the height of the materials on the conveyor belt, but the conveyor belt is actually this block location, where the block is, and this is up one. So we actually have to interact with a conveyor that's one lower. Okay, so we can check that. We don't actually have to. Nope, BR is still null. Okay, now they match. Y is 6, Y off is 1. X is 22, and X off is 17. Okay, so this is probably the other belt. Okay, here's the north belt. X off and X match. Y off. Okay, so we can check that. We don't actually have to. Nope, BR is still null. Okay, now they match. Y is 6, Y off is 1. X is 22, and X off is 17. Okay, so this is probably the other belt. Okay, here's the north belt. X off and X match. Y off is 1, Y is 6, and line is only 4. Why is that the case? Did we go in the wrong direction? Did this step us away instead of towards? Because the texture doesn't match the texture rotation doesn't match. Yeah, I remember I had that problem with something else. The rotations are in the opposite direction. So my rotation value is something else. The rotations are in the opposite direction. Yeah, I remember I had that problem with something else. The texture rotation doesn't match. Yeah, I remember I had that problem. Texture doesn't match the way instead of towards. Because the texture doesn't match the texture rotation doesn't match. Yeah, I remember I had that. Because the texture doesn't match the. Did we go in the wrong direction? Did this step us away instead of. Did we go in the wrong direction? Did this step us away instead of towards? Because the texture doesn't match the texture rotation doesn't match. Yeah, I remember I had that problem with something else. The rotations are in the opposite direction. So Mesh builder. Make lighting. This rotation value has to be reversed. Make lighting. This rotation value has to be reversed. How do you do that? You want to change 1 to 3, 3 to 1, and leave 0 and 2 alone. So you want to XOR the top bit with the bottom bit. I'll just use a lookup table. I guess you can. I'll just use a lookup table. I guess you can use form minus, or form minus, and then you have to mask the 3. I guess it's the right way to do that. What is STB prefix? What is STB prefix? It's referring to some libraries that... Oh, I rotated it to face and that made it crash. I rotated it to face and that... Oh. Oh. What is STB prefix? It's referring to some libraries that... Oh. I rotated it to face and that made it crash. And then I accidentally hit a key that caused it to bail. Okay, what is pause? 4. Why is pause 4? It shouldn't be. Should be 3, right? Oh. I rotated it to face and that made it crash. And then I accidentally hit a key that caused it to bail. Okay, what is pause? 4. Why is pause 4? It shouldn't be. Should be 3, right? That belt is 4 long. 4. It shouldn't be. Should be 3, right? That belt is... Should be 3, right? That belt is 4 long. 1, 2, 3, 4. Yeah. Interaction belt. Belt. Interaction. Interaction belt. That's here. All right. So we get the belt start, and then we're going to subtract it from. Oh no, we want to subtract it from this coordinate. Okay. So. So let's compute these as offsets. The STB are the STB libraries that are a bunch of libraries I've written. I don't know if I ever finished that sentence. So let's see, minus those, and then it's EX minus OX, Y minus OY. I know it was finding the right belt because I know it was crashing in that code. There it goes. It's eating them every so often. So then we won't put another eater. Let's let eater here and see which side this one tries to eat. It's eating from the wrong side. Okay. So wrong side. Okay. It's eating from the wrong side. Okay. So or eater. These are backwards. So this has to be 3 and this has to be 2. And let's make them eat a little less often so it builds up more. Oh, I didn't save it with the rotated. It'd probably be better if it alternated sides, but this isn't a real object, so who cares? Okay, so it's not animating them or anything, but that's fine. It's eating this one every so often. Okay, so the problem is it eats it and then they don't animate forward. And the reason for that is because I'm eating before the tick and I actually want to eat after the tick. Okay, so the problem is it eats it and then they don't animate forward. And the reason for that is because I'm eating before the tick and I actually want to eat after the tick. But if I eat, I'm worried about the flow through the thing if I do this. Oh, I forgot to save it too. We don't need this anymore. I mean, it's going to be cleaner if I just do all of the machine processing after the belt pressing. I just feel like that's going to cause flow issues. But maybe not. I mean, it's going to be cleaner if I just do all of the machine processing after the belt pressing. I just feel like that's going to cause flow issues. But maybe not. Oops. Oops, I was facing the right way. Whoops. All right. Let's save it. Let's turn it on. rotate it away and let them build up. So then we can see if it animates correctly when it starts eating them. All right. No. He eats one, and then they all jump forward on the next tick. Because when we eat one, we then have to set it to mobile. Because when we eat one, we then have to set it to mobile. Or eat item from belt run asterisk b int item. So we say b arrow items of item dot type equals 0, and then side equals item and 1, pause equals item shift right 1. If pause is greater than the arrow mobile slots of side, the arrow mobile slots of side equals pause. And then put item on belt. So calling it eat, let's say take item from belt, although it's really eating it because it's not going anywhere. Okay, so remove item from belt, add item to belt. Slot type. Slot and then add item to belt. Assert arrow items slot type equals 0. The arrow items of slot dot type equal type if the arrow mobile slots of side one pause equals slot shift right 1. So if the last mobile slot was the thing we just filled, then we need to propagate. We've filled that, so that one won't be mobile anymore, and we have to propagate that all the way back down. Which is the loop somewhere in here. Okay, what do we end up storing? If it's 0, yeah, we stored the slot that was 0. So we should probably share this code. The force mobile we don't care about, just the j less than 0 case. Okay, I think that maybe works. I'm not calling that anywhere yet, but remove item from belt. I'm not calling that yet either. All right, here. So this. Remove. All right, here. So this. right here. It's this. Remove item from belt, BR, comma, this. Wait, didn't I reorder this? Okay, yeah, I did. And I did it right. Okay. Could combine these. Maybe that would be smart. But we want to only remove it if it's the right type. And it could be that we accept multiple types. So let's hack it this way for now. We'll do the same on this. And we can just do that assert in the try. Let's just use the BR length. Set times 2. No, wait, that's not an items per belt. Right, so let's just do this. With the search. Oh, I still have to pass in the type that I added. Okay. Weights and beams. All right, that's a lot clearer. internally braces. Garbage. Okay. Compile it. Okay. Compile it. B, not BR. And I have to put the types in. So let's accept types 1 and 2 and not types 3. Just to start. Did I save that? I don't remember if I saved it. Did I save that? I don't remember if I saved it. I did, okay. So let's turn that on. So the green ones should never, RGB, the blue ones will never get eaten. And of course now the blue ones are clogging it up. Start it. Nice. Let's get started. Nice. Nice. We'd like it to back up without backing up with the blues. It's blocking up with the blues, damn it. Here we go. Will it animate forward or not? It animate forward. All right, good. Okay, so let's make the or makers so we can stop using this hack and use a different hack. Or makers so we can stop using this hack. Okay, so let's make the or makers so we can stop using this hack and use a different hack. Get interaction belt. Try add item to belt. Let's have him. Sure, we'll have him get generated at the same rate. Let's have him get generated at a slightly different rate, just for fun. Is this correct? Do I need to do anything else? Maybe that's all I have to do. Okay, so let's make the or makers so we can stop using this hack and use a different hack. Sure, why not? Why not? Sure, why not? No. Okay, right. That's not correct. Oh, look, it's already writing. The reason that's not correct is that it's, if you imagine that what it is, imagine that what that is it's a thing that's extracting ore from here and dropping it on the belt. What it actually wants to do is when the timer hits 0, it's going to attempt to start drilling again. Is dropping it on the belt. What it actually wants to do, here, and extracting ore from here. Thing that's extracting ore from here, and it is. Imagine that what that is it's a thing that's extracting ore from here and dropping it on the belt. What it actually wants to do is when the timer hits 0, it's going to attempt to start drilling again. So, if output, so first, as long as the timer is 0 and it doesn't have anything in its output buffer, so we do this at the end after we get a chance to clear the output buffer. If it doesn't have anything in its output buffer, then we start drilling like this. All right. When it goes to 0, we have to do some special processing. Switch type. So some have a special behavior when it goes to 0, as opposed to that check up there. Maybe we don't want to switch on the type multiple times, so maybe we actually do that up front. We do this. Right here. Went to 0 equals 0. False. So the ore eater just always triggers. Okay, yeah, and this should do the same thing. It doesn't need to trigger on. No, right. This one, as long as we haven't restarted the timer, we're ready to go. This one, when the timer hits 0, then we've finished drilling the whole thing, and we say output. There shouldn't be any output already. Equals whatever we're going to produce. And then if we have an output, it doesn't matter that our timer is running. We always retry this. This will mean we'll wait for a gap. If there's a gap, we'll always insert into the gap. And these do not trigger the timer. They simply clear the output. So this is a little one output buffer in each of these machines. And then if the timer is 0 and we do not have an output, then we start the timer. So we start start drilling. Something like that. What would happen if you put an eater right on top of a belt? Wouldn't directions be opposite? I'm not sure what you're asking. That's this case. You should never put them on top of the belt. Like, eventually the logistics thing is going to prevent you from, like, right now you could put a belt right on top of a belt, so then there's no room for the stuff on the belt to go through, and the plan is to just not let you build that. Or auto-destroy the thing that's in the way. So you wouldn't actually be allowed to put an eater on top of a belt. But right now, it would just ignore the one that it's on top of. It would just simulate through it, actually. But it would still just be this case, and it would actually work correctly, other than the stuff that you don't need going through. All right, so maybe that's correct. That's correct. All right, so maybe that's correct. You don't need going through. All right, so maybe that's correct. Now we'll only be outputting reds. And it should just output reds at a regular rate. And of course they get consumed. So now we put a whole bunch of these. Then either okay, good. And by the time we get to the end of the line, it should actually not be creating them anymore. Oops, wrong one. These are all queued up already because they've been sitting there waiting. Yep, okay. Now this is eating them once in a while. Yep. So every time it eats one, it'll create a hole somewhere. It'll create a hole at the back, and eventually this will actually not be able to fill because the hole will be behind where it is. Let's see what happens here. Oh, maybe not. Yeah, it can't actually catch up because the way this is working. All right, this is as expected. This is all correct. Go ahead and save that. Now we can start putting multiple consumers down. Yeah, this game is in C because it's my strongest language, but also because it lets me make things that are potentially very large. I need some tools that actually let me create larger things, so we could make a conveyor belt that goes all the way over from those trees to here. Which in the actual game that I'm picturing, you wouldn't normally do until a more advanced stage. You wouldn't want to be dealing with it. You wouldn't want a really long belt like that. But I think it's got the basics going here. It's the basics of some machines. So now these just need to actually pay attention to what kind of block they're parked on top of. And then the eaters have to actually have an output that does something. So now we start getting to what's the actual game design of the logistics thing. And one obvious... Now we start getting to... So now we start getting to what's the actual game design of the logistics thing. And one obvious, easy thing to do is clone Factorio. And to the extent that Factorio works the same as Minecraft, I don't actually feel that bad about it. So like the basic idea of having ores that you put in a furnace is in both of those games. So that's probably a reasonable starting point. But your furnace needs power. And the way you do that in both Minecraft and Factorio is with coal ore. Gives you your sort of starting furnace ability. This is all still a little weird. That animation is glitchy. Not sure why. I'm not sure I care. That might be the difference between this being an open source game and a closed source game. Like if I was going to try to closed source it and make it a professional quality thing, maybe I'd worry about fixing that. But I think as long as it's open source, I maybe don't care. Let's say that they randomly create let's say that they randomly create red and blue. Did I save that? I don't remember. I might not save the final state where I added the extra eaters. Yeah, I didn't. This will make it a little clearer what's going wrong with this animation here. Yeah, okay, that's animating but not simulating problem. That's why those flip colors. So, I fixed one of those already, but I obviously have more. Oh, because I go, when I update a belt, I say, oh wait, it changes which things are mobile, but it doesn't propagate that back to the previous things. Oh, but it shouldn't propagate for sideways. Sideways mobility, that doesn't work. But it would affect the crossing the... what is that on P? No. Yeah, but I don't have anything crossing. Yeah, well, the fact that... Yeah, well, the fact that these aren't color-coded for what they eat is because this is all just temporary hack stuff. Like it's, you know, your furnace we could say that furnaces can take any kind of ore and output any kind of ore. You wouldn't want to feed the same kind of ore to it necessarily, because then you'd have to sort it later. And you generally, the whole feel of Factorio is to sort of avoid the smart sorting, the intermixing on a single belt. Instead, you try to keep everything separate intentionally. That seems to be, at least in the Let's Plays. Yeah, that's going to be annoying, but there you go. There's the beginning of a sort of Factorio feeling thing. And then let's save it. And then let's bump out our view range and run in release mode. So where do we handle bump out our view? And then let's bump out our view range and run in release mode. So where do we handle the view range? That's probably in data. View disk log 2. Minimize memory. And it'll have a slower startup now, because it has to build more mesh data at start. Not too bad. Still building the mesh data into the distance right now. Is the fog? It's just not drawn, it's not built the stuff that's into the fog distance. So there's my machine right there. You can't make it out at all. I can't make it out on my screen. I'm not doing any level of detail on the rendering of that stuff. It's currently just going to render all of it if I built a big thing. And my frame rate is pretty twitchy. And the flying view smoothing is frame rate dependent, I think. Yeah, the render time, frame render time is up pretty high. We're not building meshes anymore, except the cache size is changing. It's claiming it's not building any meshes. Weird. But the cache size is continuing to grow. Oh, yeah, okay. I think that was just always weird. Q chunks. It's only drawing 14 million triangles. I'm not sure why it's glitchy. I don't think that's a simulation. The simulation there isn't actually very much being simulated right now. Which direction? What's the simulation? Where are my things? Don't know what that glitch is. Nope, it wasn't here. I've lost it. It's the origin. Where's the origin? Oops, now my X is increasing. Oh, I had the right direction and then I lost it. X is increasing. X is increasing. X is increasing. Why is X increasing no matter which direction I go? Oh, the flickering is because I still have the debug rendering on. Oh, right, yeah, the chunk boundaries. All right, X is decreasing, but Y is increasing. Y is increasing worse. Okay, so it's this way. I don't see it. Oh, I way overshot. That's how big this world is. I have no idea what I'm doing. There it is. It's right there. But anyway, so you can see that the current simulation, nothing is getting allocated. The allocations all only happened during the when I'm creating and removing blocks. This simulation doesn't require any allocations, so it's all super fast. That comes from that choice that I made to have the belt runs always store all of the have enough slots for when it's full. Which I think is the right call then, because now there's no dynamic allocation in that path. So only when you change things does it require allocations. All right, so I'll check that in. All right, so I'll check that in. And then we have to start making real machines that aren't hacked. So I guess that means doing the inserters I'm sure I want to go that route. Don't do this. So I've been streaming for 2.5 hours. So I think I'll take a 15-minute break. So I'm going to stop. So I'm going to stop for 15 minutes, and we'll come back and continue from the same thing. I'm not going to bother announcing on Twitter the restart, so you just have to come back. Actually, let's aim for on the hour, which is 20 minutes from now. And that's going to be part 2 of this episode rather than a separate part. All right, so see you in a little bit.